Hello YouTube family, James Green, Short Series Shenanigans. So, this is going to be the first job we're doing with Bridget since we got our American rotary phase converter up and running earlier today. And today is, in fact, Memorial Day. Been busy the last several days with stuff. So, we finally, after doing a little bit of back and forth to the Home Depot to get correct connectors for our strain connectors. There we go, I'm sorry. Because this wire, this originally was really short, and as you guys remember my other videos, this was like tilted over at an angle. So we've got this straight up and down, and we've already got it all cleaned up and everything in the back. So whenever I do get back from the bash, because I am going to take this down before I go, take it apart, because we know that it's noisy up there. There's a bearing in there that's, so this, you guys have heard this mill before. It's noisy. The only thing I have running in the background right now, and because everyone always asks, what kind of camera do you got? Well, I have a Canon Viexa HF6, I believe. I'll have to look at it here and see. But anyway, so it has its own microphone. It's very, very good microphone. You guys can hear I've got a fan running. I've got the air conditioner running, and like when that's not running and it's quiet in here, at times you'll hear my hot water heater go woof. So just know that this microphone is really, really, really sensitive. It picks up a lot. I like it. So I noticed when I played back the video from the first time I turned the rotary phase converter on, it actually sounds louder than it really is. So for those of you out there in video land, is what I'll call it, in YouTubeville, you're like, man, that's loud. Actually, it's not. And I noticed that on the video. I'm like, man, that sounds loud, but in person, it's really not. I even flipped on this and then turned my lathe on, and when my lathe is running, I can't even hear this. And now my lathe is single phase. So just know that when you guys hear this, it's not that loud. It might sound loud on video, but trust me, it's not. Anyway, so what we're working on, this first project, this was one of those that got put on the back burner when the mill went down. Roll back several months in the fall when I did the hydraulic valve body rebuild, and I've had a lot of response in reference to that, and I may have another hydraulic valve body job on a piece of equipment here in the near future. It'll probably be after the bash. And so anyway, to premise what we're doing on this old trencher, what it is, it's a 1974 Davis Fleetline 30+4. I've posted pictures up on social media, Instagram, and then my Eagle Dust Off 37 Facebook page. This thing, I know, has 20 to 25,000 hours on it. Dad got this thing from the original owner in 1984, and it had less than 500 hours on it. Yours truly has spent a lot of time digging a lot of ditch with that trencher. So one of the wear items on the back, if you guys are familiar with these small little trenchers, the rotary digging chain on the back, it is driven by a hydraulic pump and then a real wide flexible link chain, or just a bicycle type chain, to kind of leave it in layman's terms. And I know guys are going to comment in the comment section, that's not what it called, here are the proper names. Feel free, comment away. I love it. Anyway, so it is a 3/4 inch wide chain. Now, one of the main drive sprockets that turns this is a consumable item. They wear out, and that's what we've got here. I know from past experience that the holes in those, because we've measured them before, we always have to turn these sprockets out, because I don't know what it was in the manufacturing process. And this is actually made by Martin Gear. Now, this gear along with all these other parts for the digging chain, which they're consumable items. These were ordered back in 2008, and we ordered them back then because it was like, we ordered some other parts at the time, and it was like, okay, we know in a couple of years, at the time, we were like, okay, in a year or two, we're going to have to replace the stuff at our current usage rate. Well, we haven't done a whole lot, but it was like, okay, it needs to be replaced. So it's like, while you're ordering stuff, go ahead and order it now, because things always go up. So I'm sure, 2008 versus now we're 2016, things have gotten quite a bit more expensive. So this was actually sitting in one of the containers out there at the ranch. I brought it in. It has the factory little bit of a surface rust, and that's the nice thing about New Mexico. You don't have to worry about things flash rusting out here. So I have to go in and I measured it. I measured it in like 4 different places with a snap gauge. I could go in doing the bore gauge thing and everything, but I will show you here what I did just to make sure. And every one of, I don't want to loosen it, but on the bottom here there is you can see there's kind of an outline where it was welded on a hub, and it takes a 1 3/4 inch diameter bore. Now it has a slotted keyway, and it has an Allen or a set screw that sets and holds the keyway in, because it's keyed onto a shaft, and there's another Allen that comes in from this side here, okay? And so, because if you do not bore this round again, because in the process that hub is welded to this gear, it warps. And I don't know what their process, it's even pretty roughly bored at that. I have struggled in the past trying to put these off or on without doing that, and you end up, you fight it all day. So we came up with a solution many years ago of, okay, go in here and make sure this is true. Okay, because what else holds this on here is as it slides on the back side, because this is the back side, you won't see this. The front side is over here. There's actually a big snap ring that goes around and helps hold this on in conjunction with the 2 set screws. This will not come off. So what we actually do is we go in here and we bore this out, either on a lathe or the mill, and rather than pulling the gap, I could run it on the lathe. I thought, let me go ahead and set it up in the mill, and let's do this as the first job on Bridget with the new phase converter. We've got our little boring head set up here. I've already done the basic, centered it up. We're 875 thou. I came in and touched up. I had another walk you through it real quick so everybody is curious, how did I do it? I keep it simple. I threw a chucked in. Okay, I threw an all brick chuck in. I use this, it's a spotting drill, as my center point. Okay, I came over here, found the edge. Okay, came over and I used my dial, zeroed it, 875 thou. Came over here, found this edge, found it, lowered it down, 875 thou, moved it back, boom, that's our center. We locked our table down. So that's how I found center. Again, there's a myriad of ways you could use a coax indicator, and I like to do things because this will work, okay? And when this goes on, we actually I use Loctite number 262 thread locker. That's the permanent stuff. That means I am not going to take this off, if ever. Now, at the rate that this machine gets very little use now, honestly, more than likely this will be the last gear that this trencher ever gets on it. Depending on usage, they would last about every 4 or 5 years, depending on the amount of use that it got. Now that the old man is retired, and some people might take offense to that, but that's a term of endearment I use with my father. So me and my dad and I, He has since retired. So this machine is mine now. I pretty much do anything with it I want. We have one last trench, a long one. It's about 6/10 of a mile, a little bit over. We have to dig. So that's what's going to help Loctite this on in place. We're going to go in here. We're going to true up the bore, and I've already measured it with a snap gauge, and I checked myself in 4 different areas. This thing is not cylindrical at all. It's off by about 3 thousandths. So we're going to go in here, we're going to true it up, get a nice looking bore in here. I thought about using flood coolant, but I thought no, it's not, because it's just a mild steel. It's not anything special, and so we're just going to utilize our sulfur-based cutting oil, the dark stuff. So we've already got everything set up. We'll go ahead and double check, make sure everything's locked down here before we get started. Again, that was a lot of stuff I didn't want to mess with on camera. Make sure that's so it doesn't come out. Okay. And we'll come in here and touch off. We know we're going to start wiping here on this side. Tighten. Okay, and we're going to go ahead and start our rotary phase converter. And here we go. Like I said, not that loud. When you got a fan running in the background, that's actually louder. So we'll go ahead and start with a little, go ahead and slather the inside of it here pretty good. Just so we got some in there. Everywhere. Alright, good coating. We'll go ahead and get started here. I'm going to actually slow that down. Let's go to, because that was 1150. We'll slow it down a little bit. And now that I have a 3-phase rotary phase converter on here, I actually have a full 1 horsepower. So for those of you that don't know, whenever you use a static phase converter or a VFD, there's a sacrifice somewhere. There always is. It's a little give and take. So, not having to sacrifice horsepower anywhere now, I'm gonna create something a little bit better so that'll tighten like I want it to. There we go. So instead of having the trade-off of losing horsepower or different things, I have the full ability of that. Okay, we are at 660. It's a lot better. And you heard the phase converter kind of lug down a little bit there. And we're going to go ahead and got our feed on. Feeding earlier. I don't know why it's not feeding now. Let's see. Make sure we're locked in correctly. Let's try that again. might feed it by hand. There we go. There we go. Now we're feeding down. And we're feeding at the center mark, which is 1.5 thou per rev. And we're just going to let it manually feed down. I think I'm going to slow down even more. Yeah. All right, let's try. We're going to go down to 80 RPM. We'll slow it way down. With that interrupted cut back there, that was just a little bit too aggressive. That was a little bit of rodeo machining there. There we go. I can see where it, yeah, it's that one side, I was right. It's right here, this was the side where it's almost like it's egged like this. Just want to double check myself. That's where I measured it, just, you know. You always kind of, is it messing up? You know, you have that pucker moment. But I measured it several different directions, and the measurement across this way, kind of the angle of view, right here in this area, across, was actually narrower than the measurements I took this direction across here. So it's like between 2 and 6 and 3 and 7, or 230 and 330, or actually 230 and 630 was narrower than say like 10, 1030 and 11, and over here between a clock, kind of the clock position of it. But this is actually, and when I get done I'll flip it over and you guys will see it, is actually wire welded on there. And see, you can't even hear the rotary phase converter over this. The belts in the mill make more noise than that rotary phase converter. Heck, me talking, I make more noise than that thing. Going to let it feed down and go through. I'll try to get you guys a better angle so you can see the action. It's not cutting there. I'll actually move the camera so you guys can see what's going on. that's the side where it's actually cutting on. We'll just let it go down through there. Matter of fact, over here is the Martin Gear information, where it says Martin Gear, and they give the number 80 Bravo Sierra 451 and then 3/4 and the number H at the top, or the letter H at the top. So that's the part number for this whole gear assembly. We're just going to let it cruise down through there, and that's all it's going to need, honestly. We might open it up about another, I'll measure it after this, and we're going to let it take a long cut, and you're not going to get to see all of it on camera, but we'll let it go through and do its job. So here's some of the tools we used to check it. Good old snap gauges, and we used our Starrett 216 1 to 2 inch. Going down there nice. Like I said, when I first measured it, I was I don't ever presume anything is true anymore. It's, you always come in here and measure it, and I measured it at 4 different areas. I didn't just take one and say, okay, that's good. I started off, about 1 o'clock, and then I moved to 3, and then I moved, I would call that my pointer. So I did 1, I did 3, and then I came around to 5. And in those areas, I was able to tell that, and we can obviously see there that that's the area where, and those measurements were true, because this measurement here was narrower than the other measurement this direction or up here. And so, and that's just, whenever they welded that, I guess it warped. Who knows? No telling. But we learned this years ago, don't presume when you get one of these from the gear, and Martin builds good stuff, but in the manufacturing process, things get warped and they're not cylindrical. So, and like I said, where we put this valve body on this trencher, it's, there is no electricity out there. It's a generator, and where it sits out at the ranch is by a little living facility we have out there. So anything you can do to make putting parts on easier, you do. Matter of fact, I still have to go pull the old one off. What I'm going to do with the old one, I'll tell you while this is boring, is I'm going to be taking my big gator tools, my drill and tap guides, because like I said, on that other side there's a big, and I've showed pictures on social media, there's the hub that sticks out, and it sticks out about 1 inch or so, and it's relatively large. What I found the easiest way to pull those off is, you can't get in behind here and wedge these off, because they've been locked, everything's Loctite. Trust me, that Loctite wears out, but to get them off, so you don't mess up that through shaft, because we've done that before, is you take, and I have a bolt puller set you use like for harmonic balancers, and you go in there and you drill and tap 3 holes, just like on it for a harmonic balancer. You put some grade 8 bolts in there and some heavy washers and an air impact, which we've got a small compressor out there, so we can use an air impact. We don't have to do it by hand, and zip, it comes right off. Otherwise, you'll fight it and fight, because that dirt that gets down in between there, you would never get it off. So it's probably going to take another 10 minutes to go through, and you guys are going to see it on video. So there you go. Ginning right along. Our first official job on Bridget with the new phase converter. So there you go. And I will try to get some video when I don't know when I'm going to get out to the ranch to put this on, but I'll have video of kind of before, during, after, little snippets to put up on the channel. So there you go. Thanks for watching. You guys, click the subscribe button down at the bottom. I greatly appreciate all my new subscribers. Spread the word about the channel. If you guys have any questions, you know my public email address, eagledustoff37@gmail.com. So, back at it. Getting the whole board out on this gear. You guys, take care of yourself, take care of your family. Because remember, at the end of the day, you and your family is all you got. Until next time. Get out in the garage. Make some chips. Because you know what? This stuff is fun. Have at it. We'll talk to you later.